Hello, my name is Alaf Sagateros from Compute and Beyond. We develop softwares, create tutorials, and YouTube videos. Okay, in our previous video, we discussed about SHA-1 algorithm and also about Git states and sections. And in this video, we'll be discussing about the basics. Okay, we start with installing Git. You can download and install Git like any other software. We'll create a project name Git example or any kind of name. We have two options. The first is creating local Git project or cloning a Git-based project from network into our local machine. And we'll be using the first option. And we start by typing the git command which is init, and after that we'll take a snapshot, and this snapshot will be recorded permanently by using the command git commit, and we'll try to look at the history by writing the command git log and git status. We'll try to undo actions using git reset or checkout, and at the end we'll look at our immortal work. And let's see the life cycle of the status of our files within, of course, Git project. Whenever we start to create a new project, it's on untracked state. And after we take a snapshot, which is creating a binary object referred by 40-digit hexadecimal value, it will go into the staged state. And after we take it to the staged state, we commit it. And when we commit that binary object, it will be onto the unmodified state, and after that either we delete it or remove it from a Git repository, or we can edit it, and if we edit it, it will be modified because what Git says within its database and working directory is different, so it's flagged as modified. Then after we edit it, we can stage it or take a snapshot of the new or modified file, and this snapshot can be either committed or we can leave it as it is. And the cycle goes within this cycle, within this states, from unmodified to modified, and from modified to commit, and it's like a cycle. And we have those commands. We start with status, init, add, commit, diff, reset head, checkout. Let's see how Git work with snapshot and commit. Of course, in our previous video, we saw how Git takes snapshot by creating the binary object referred by 40-digit hexadecimal value. And as we can see, we have two files named a.txt and b.txt, and they have values. And these files will have their own binary objects as depicted with this green files, and these files will be referred by 40-digit hexadecimal value, and this is the snapshot of those two files, and this specific snapshot will be referred when we refer to the commit action, will be referred by commit action using another checksumming using 40-digit hexadecimal value. And this commit action will also have email, the name of the user, reference to the previous commit, the commit message, and reference to the snapshot, of course, as we are seeing this arrow. And as we can see here, the commit is being referred by snapshot, and whenever we try to create a new commit, this new commit will refer, of course, its previous commit, and will refer its own whatever snapshot we try to give it. whatever snapshot we have within here will be referred by this new commit action. And also if we create another commit, this will of course refer to its previous commit and refers to its own snapshot. And yeah, the chain goes on and on. And this is how commit in the snapshot works. We create a snapshot, and this specific snapshot will be referenced by a new checksum value, which is 40-digit hexadecimal value. And while we are doing this, our latest commit will be referred by a tag, and by default, whenever we create a new Git database, a new branch named master will be created. This is just a tag that refers to the latest commit, and it can either refer to this commit, and in our diagram it can refer to this specific commit, which is the latest commit. And of course, to refer to the current branch, because we can have plenty of multiple branch, to refer to the current branch, it can be referred by another tag named as head. Okay, good heavens. It can be referred by another tag named head. And whenever this head goes to any branch, and that branch would be the current branch. And as you can see, this path of the commit, and we can refer it using another picture. As you can see, this specific line is what we call branch, and we can have plenty of branches, and we'll discuss it in our next video. And let's go back to our project and try to create a Git based project, of course. Okay, in our project, the name of our project is gitx example, as you can see here, and we have two files, A and B, and we're referring using our command line. And we start by asking if Git is available, and we use Git version command, and you can see it's here. And after that, we'll start to create Git database for this specific project, and we type Git in it, and we have created the database, and this database will refer to the working directory. And we can start by typing git status, and as you can see, start from by creating a default branch named master, and there is no commit yet, and of course no snapshot too, and we have untracked files, which means Git database do not have any record of those files named as a.txt and b.txt, those two files, and they are in red. And we have this command called git add file to include what will be committed, so we can create a snapshot referred by 40-digit hexadecimal value by typing git add dot, which refers to the entire project. And we hope it has taken a snapshot of those two files. And let's see git status. Yeah, and of course we are still in our branch master, no commit yet, and we can see that the new files, which are both A and B, have been taken a snapshot. Their binary format is available, and what is left is the commit action. So we can commit. Of course, we have seen within the diagram, which we will see right now. As you can see in this diagram, we have this snapshot. This snapshot was taken by typing git add, and after that, okay, we took a snapshot, and after that we will be taking a commit action, and this commit action will refer to the specific snapshot, which it will have attributes like email, name, previous commit message, and refers to the snapshot, which is of course this specific snapshot. And we'll see that by typing our commit command. And we're typing git commit -m or new commit. The message can be anything, just it must refer to what action we are doing. And voila, it's saying the master, which is the root commit, which is the beginning, and the commit message is this, our new commit, and it is the files are in create mode, and 2 files have been changed, and blah blah blah. And we can look at the commit history by typing git log, and this git log can start with the 40-digit hexadecimal value, and this 40-digit hexadecimal value do not refer to the snapshot 40-digit hexadecimal value. It refers to the commit action that refers to the snapshot 40-digit hexadecimal value. And yeah, that's pretty much it. And we can see within the diagram, in our command line, we saw the 40-digit hexadecimal value, and it refers to this specific key, not this one. So make sure you understand this concept. And other than this, it has, of course, the head tag, which refers to this master branch, and this head tag will refer to the current branch which of course we are working on, and we don't have any other branch. Yeah, and other than that, the attributes like the name of the author, email, the dates, the commit message are all referred here. And this is how the snapshot is being permanently saved in our Git database. And we can change the files by simply changing the content. Hello again, we can write anything. We have saved it, and let's see if Git can track the change, or if it knows if it's been modified. Git status. Yeah, and as you can see, we are on our branch master, and change not stage for commit because it's been modified. And of course, you can see it says being modified a.text. So we have two options. Either we can take a snapshot of the new change by typing git add in the file name to update what will be committed for the next commit, or we can check out the files that were previously snapshot and taken to our Git database permanently by our commit action. So we have two options, and we can discard the change in our working directory. Perhaps we can use this, and what we can do is simply by typing git checkout and the file name .txt, and let's see the file. Yeah, the new edited or the modified content is vanished. And how does this happen? Let's see. Okay, we saw what we did, and we changed the file within this. We saw the content of this file, and it tracked that it was modified. And what we did was we tried to recreate what was within this snapshot by calling out this binary object to be recreated and replace this specific a.text file, so that the modified content will be replaced by the originally saved binary object. Okay, and we're back to our commands, and we saw what this git status does. This one, git add, git commit, and this one. Okay, git diff, and it shows the different status between working directory and the git dev directory. Whenever we change the files within our working directory, and when we try to see the difference between the what was within permanently saved in our git database and working directory, we can type this git diff and can see what has been changed. For instance, we can try something and try to see the difference. Yeah, as you can see, I have a new change here saying try something, and when what was added, and yeah, basically it tells you everything within this the file named a.text. And also we have git diff staged, and it specifically address the files that were staged and nothing else. But in our previous command, git diff can see the entire difference between the working directory and the git directory. And the other command is git reset head, and it removes the snapshot. Whatever we created as a snapshot using the 40-digit hexadecimal value will be removed. And we can try it. For instance, if we had added something and we try to see the git status, and we can simply remove the staged content, and by typing this git reset head file, by simply typing git reset head a.txt, unstaged change after reset. So as you can see, the modified thing is removed, and we can go back and see the status saying it's modified, but it's not staged, so we can remove the snapshot. So these are the basic commands we usually work with when we're working on the basic stage. Thank you for staying with me, and I'll see you in the next videos. Good day.